This is lesson number 66, page 1. And at the top of the page, you see these 5 different factoring patterns. We've talked about this one a little bit, and a tiny bit about 2 and 3. 4 and 5 are brand new for today. So we'll start here. This is a difference of squares. If you look at what this really, consider what this really means. You have the square of something, take away the square of something. This is the square of x, and this is the square of 6. So we have the square of x, take away the square of 6. So we don't have to do guessing and checking or AC method or anything. If we have the square of something minus the square of something, all you have to do is determine what are these the squares of. Put them in both sets of parentheses, x and a 6 and an x and a 6, and make one of them plus and the other one minus. Make one of them a sum and the other a difference, a subtraction. It doesn't matter if you put the minus and the plus or the plus and the minus, just so the signs are different. Okay, next one over. Here's the square of x. Take away the square of 4. So I can write this x minus 4, x plus 4. Too good to be true, but it's true. It's that easy. This is the square of something, that's the square of x, and this is also the square of something, that's the square of 11. So I can write this x plus 11, x minus 11, or x minus 11, x plus 11. It doesn't matter which order you use. Okay, next row. This is the square of 5. This is the square of x. Now, when we subtract, as I've been saying since January, the order is important. So since it's the square of 5 first, and then minus the square of x, for the subtraction set of parentheses, we got to make sure we have it 5 minus x, not x minus 5. Okay? That's the square of something. What about that? That's the square of x. That's the square of 1. 1 times 1 is 1. And so I can just write x minus 1, x plus 1. And this is the square of 1. Take away the square of w, which allows us to factor it, or rewrite it 1 minus w, 1 plus w. 1 minus w, 1 plus w. What do we got here? That's the square of x. Take away the square of 10. And so it's x plus 10, x minus 10. If you multiply any of these out, you're going to get the first two things together will make the first thing there. See, there's x squared. 10 times minus 10 will make minus 100. And doing these and these, that'll make a minus 10x and a plus 10x adds up to 0x. No middle term. That's why this works. I was getting just ever so slightly more involved. This is the square of 3x. 3x times itself, 3x times 3x produces 9x squared. And that, of course, is 7 times 7. So now we're ready to write the factors. 3x minus 7, 3x plus 7. Okay. Now here's the square of x, and here's the square of 6, but since it's got plus in the middle, this is prime. This cannot be factored. If you try, if you have nothing better to do for a few hours, you could try putting whatever you want in here. You're going to have to put an x and an x. And then what could you possibly put here? Plus 6 plus 6? Or minus 6 minus 6? Or 1 and 36? Try it. You'll see it does not work. It'll always give you a middle term of a 12x or a minus 12x as well, and that's just not the same thing. So this can't be fact. me write those words too. Can't be factored. Why not? Because it's a sum of squares. When we get to third power in a while, sum of cubes can be factored, but a sum of squares cannot. And this is getting a little crazy. Is this the square of something? Remember that a power of a power, you multiply the power. So if we put a 4 there, x to the 4th squared is x to the 8th. So this is the square of x to the 4th, and this is the square of 9. So this is x to the 4th minus 9 times x to the 4th plus 9. And I have some terrible news. That's not the end of it. See, there's a sum of square. That's the square of x squared. That's the square of 3, but it's got sum in the middle. This is the square of x squared. That's x squared squared. That is 3 squared. So we got to do this again. This part of it will break down into x squared minus 3, x squared plus 3. This, we just copy it. We don't want to lose it, but this will not factor any further. But the complete factored form of x to the 8th minus 80 minus 81 turns out to be this. Okay? And the ever increasingly exotic, this is 2x to the 5th squared. So if you square this, you're going to square the 2 and get a 4, and when you do the power of a power, you multiply the powers, you're going to get the x to the 10th. And this, of course, is 7 squared. So this will factor 2x to the 5th minus 7, 2x to the 5th plus 7. We don't have to go any further this time because these are not perfect squares. Here's more trouble. Well, I shouldn't say that. This should be fun, right? This is the square of x squared. This is the square of 4. So this will factor into x squared minus 4, x squared plus 4, and we're not going to stop yet because this is the square of x minus the square of 2. So that factors into x minus 2, x plus 2, and this guy is a sum of squares, so he does not factor any further, but of course we don't want to lose him. Okay? That takes us to the bottom of this page where we have another factoring pattern. Perfect square trinomial, which is number 2 or 3 at the top of the paper. Let's take a quick look at those. See, you've got this factor pair if you see in your exercise, in your trinomial, what's hidden. Do you have the square of something and the square of something at the beginning and the end? And if the answer to that is yes, if you multiply those things together and then double it, do you get the middle term? See, this is 2 times a times b. A being what's ever squared there, and b being what's ever squared there. And this one, the only difference is you got negative 2 times the product of those two things in the middle. So let's see. Does this work here? X squared plus 10x plus 25 is a perfect square trinomial because this is the square of x and this is the square of 5. If you times those together, you get 5x. If you double it, you do get exactly 10x. And that will factor x plus 5, x plus 5. Does this fit the pattern? That's the square of x. That's the square of 3. If you do 3 times x and then double it, do you get 6x? Yes. And so we don't have to do anything fancy. Once we've identified what's playing the role of A and also what's playing the role of B, and it fits the pattern. You got the a squared, b squared, and 2 times a times b. Just write your a and your b twice. In fact, if you want, that's the word or, you could just do this. If you're as lazy as Dane, you only have to write one set of parentheses with an exponent 2. Does this fit the pattern? That's the square of x. That's the square of 7. 7x. 7x. Double it. Precisely 14x. So I'm just going to write x plus 7. X plus 7. That's the end of page 1.